board, China's memory crunch is now bleeding into a corner of the semiconductor industry that almost nobody talks about. A Chinese supplier named Giantech Semiconductor has reportedly informed distributors that prices across its entire NorFlash product line will jump by 25% starting July 6th. And this is not just for fresh orders. The board increase also applies to outstanding orders that have not yet shipped. That is a heavy move for a component that typically gets far less attention than DRAM, high bandwidth memory, or solid-state drives. NorFlash is the compact, dependable memory that stores firmware, boot code, configuration data, and essential instructions inside automobiles, board routers, industrial machinery, telecom equipment, and countless connected devices. Without it, a huge number of electronic systems cannot even power on properly. Contract pricing for mature memory products already shot up dramatically during the first half of 2026. Artificial intelligence infrastructure is swallowing investment, board, capital, factory floor space, and customer focus. Automotive systems and edge AI devices are demanding larger portions of reliable embedded memory. And now one Chinese supplier is slapping another 25% onto its price sheet. The real question is whether this is a temporary adjustment from a single company or whether the global board memory shortage is now flooding into the overlooked chips that keep the world's electronics. Board alive, board what NorFlash actually does. NorFlash is not the same thing as the DDR5 memory sitting inside a gaming PC. It is also completely different from the NAND flash used inside an SSD or a smartphone storage module. The simplest way to grasp NorFlash is to picture it as instruction memory. When a device first energizes, it needs a trusted location to board find the initial code it will run. That code might initialize the processor, check attached hardware, load safety parameters, verify cryptographic keys, and prepare the operating system. NorFlash is perfectly suited for this job because it retains data when power vanishes and permits fast, direct access to stored instructions. A vehicle may use board NorFlash inside engine control units, infotainment systems, driver assistants, computers, cameras, radar modules, telematics boxes, and digital dashboards. A network switch may rely on it to hold boot firmware and configuration data. An industrial robot may depend on it for control software that must survive vibration, extreme heat, and years of board non-stop operation. A product packed with powerful processors and expensive sensors can still become a brick if its boot memory is absent, unreliable, or stuck somewhere in a supply chain. Board backlog. Board, why prices are climbing right now? Mature memory products like NorFlash and SLC NAND are frequently built on older process technologies. Those production lines still work perfectly well, but they do not generate the same buzz or profit margins as bleeding-edge AI memory. The giant semiconductor manufacturers are pouring investment into board high-bandwidth memory, enterprise SSDs, advanced DRAM, and next-generation NAND products. Those categories are being bought in staggering quantities by cloud operators constructing AI infrastructure. Factory tools, engineering talent, capital budgets, and wafer allocation are therefore migrating toward the products with the richest demand, and board fattest margins. Suppliers have very little incentive to build large amounts of fresh, mature node capacity when investors and customers are laser-focused on AI. Modern automobiles now pack more electronic systems than ever before. Digital cockpits, advanced driver assistance, connectivity modules, over-the-air update mechanisms, cameras, radar, board, battery management, and intelligent lighting all demand firmware. Edge AI devices also require more local code because they process information near the user instead of shipping everything to a distant cloud. As software stacks grow more complex, manufacturers are migrating toward higher-density NorFlash parts. That creates intense pressure on a board market where supply is already becoming less. Board elastic board, the 25% shock. According to current industry reporting, Giantech's new pricing takes hold on July 6th. The hike covers the company's entire NorFlash portfolio and bites on both new orders and undelivered existing orders. Normally, customers operate under the assumption that an accepted purchase order locks in the price and board shields them from a later adjustment. Applying the new rate to outstanding shipments strongly suggests the supplier sees the market tightening fast enough to reset terms immediately. This does not mean every NorFlash manufacturer has raised prices by exactly 25%. It does not mean every chip buyer will hand over the same amount. Board, large customers may hold long-term contracts, negotiated allocations, or different product configurations, and a 25% jump in one component does not translate into the final price of an automobile server or router rising by 25%, but the decision signals demand robust enough and availability constrained enough to board push prices across an entire category without waiting for the next quarterly negotiation. Board cycle. Board, a broader memory shockwave. TrendForce reports that contract prices for NorFlash and SLC NAND surged by more than 100% during the first half of 2026. The research firm expects additional increases during the second half because meaningful new capacity is not arriving quickly. When demand spikes unexpectedly, board manufacturers can sometimes relieve the pressure by running existing fabs harder or draining inventory. That becomes extremely difficult when the underlying production footprint is actually contracting. Mature memory is not the highest growth destination for semiconductor capital. High bandwidth memory can sell for vastly more than a tiny embedded board flash chip. Enterprise SSDs are being secured through large multi-year purchasing agreements. Advanced server memory receives priority allocation because cloud companies are willing to pay aggressively to lock in supply. The result is that mature products can become painfully scarce even while total global memory investment is climbing. The board industry is building more memory overall, but not necessarily the specific types every customer urgently. Board needs board why automobiles sit in the danger zone. Automotive companies are particularly exposed because they cannot swap a qualified memory chip overnight. A consumer gadget maker might redesign a board or switch suppliers relatively quickly. A vehicle component must pass punishing validation for temperature, extremes, vibration, reliability, and extended board operating life. Changing one part can trigger new testing cycles, software re-verification, documentation updates, and regulatory reapproval. Automakers also require predictable component supplies stretching across many years because vehicle models remain in production and need replacement parts long after the initial sale ends. This dependency board hands approved suppliers considerably more pricing muscle when capacity tightens. Driver assistance systems need firmware for sensors and processing modules. Connected vehicles demand secure boot functions and update frameworks. Higher automation levels can multiply the number and sophistication of electronic modules throughout the vehicle. A board shortage of relatively inexpensive NorFlash can therefore halt production of a far more expensive finished automobile. Factories have been forced to slow or stop entirely because one missing controller or memory chip prevented a complete vehicle from rolling off the board line. Board AI servers are next, but context is everything. Saying cars and AI servers are next does not mean NorFlash will replace HBM or suddenly become the biggest memory cost inside an AI server. Servers, network switches, accelerators, storage controllers, power systems, and management boards all demand firmware. As AI data centers swell, they deploy board enormous populations of devices that must boot, authenticate, communicate, and recover reliably. Every additional server rack contains a multitude of embedded subsystems. The volume of NorFlash per device may be modest, but the sheer quantity of devices is exploding. AI clusters depend on high-speed switches, optical modules, smart network, board interface cards, and management controllers. These systems consume dependable code storage for startup routines, configuration files, diagnostics, and updates. Edge AI hardware creates yet another demand vector. Cameras, robots, industrial computers, vehicles, and smart appliances increasingly run machine learning models locally. That demands more. Board sophisticated firmware and frequently larger embedded memory capacities. So AI contributes to this squeeze in two distinct ways. It pulls massive investment toward premium memory like HBM and enterprise NAND. Meanwhile, it simultaneously pushes up demand for these smaller firmware chips woven throughout the entire infrastructure. Board fabric. Board, China's position in this fight. Giantech is not the largest memory company on the planet. Samsung, SK Hynix, Micron, Kioxia, and other major players control vastly larger slices of global memory output. But China has been systematically expanding its footprint in mature and embedded semiconductor categories that carries weight because domestic board customers want secure supply channels for vehicles, communication systems, industrial gear, and consumer electronics. Chinese technology firms are also actively trying to reduce reliance on foreign components wherever feasible. A stronger domestic NorFlash industry can directly support that strategic objective. Yet, higher Chinese prices, board demonstrate that localization does not automatically translate into cheap supply. Domestic manufacturers still answer to capacity constraints, demand fluctuations, equipment costs, yield curves, and market dynamics. If Chinese automakers and electronics companies end up fighting over the same limited output, prices can climb inside China even board while domestic production expands. The shortage could benefit suppliers through richer margins. It could also stimulate fresh investment and additional capacity. But new semiconductor output requires real-time equipment must be ordered, installed, qualified, and run at acceptable yields. Customers must then test and validate the finished chips. Board, the market may stay tight for a considerable stretch before any new line reaches meaningful. Board volume, board who ultimately swallows the cost. The immediate buyers are distributors, module makers, electronics manufacturers, and system integrators. They must decide whether to absorb the higher input cost or pass it forward. For an expensive vehicle or server, one NorFlash chip may represent only a tiny fraction of the final sticker price. Manufacturers, board might instead accept slimmer margins. They may negotiate harder with suppliers, draw down inventory buffers, defer projects, or redesign future products around alternative components. Smaller companies have fewer escape routes. They purchase lower volumes, wield far less negotiating leverage, and may lack already approved second sources. The board could face stretched lead times or even steeper price escalations. The most serious danger is not the added cost of one chip. It is outright interruption. A missing component can stall an entire board, controller, machine, or vehicle assembly line. Companies may therefore pay a stiff premium simply to guarantee allocation. This behavior can board actually worsen the shortage because customers start ordering earlier and hoarding more inventory than board normal board. What could finally break the shortage? Several developments could weaken the price surge. Demand for AI hardware could decelerate, automotive production could soften, customers could trim memory density requirements or redesign products around alternative devices. Manufacturers could reopen mothballed lines, improve yields, or shift capacity back. Board toward mature products, Chinese suppliers could expand faster than current projections anticipate. But every potential solution carries its own constraints. Redesigns consume time. Automotive qualification is painfully slow. Building fresh capacity is enormously expensive, and suppliers may prefer to keep production disciplined rather than trigger. Board, another devastating oversupply cycle. Memory companies carry deep scars from what happens when too many factories chase temporary demand spikes. Prices crater, inventories balloon, and expensive equipment sit severely underutilized. That brutal history encourages caution. The market may eventually find balance, but buyers should not assume. Board pricing will snap back quickly to previous board troughs. Board, what this does not prove. One supplier's notice is not proof that every electronics category is staring down an immediate crisis. Giantech's increase must be carefully separated from broader claims. We do not know the exact price paid by every customer. We do not know how much inventory distributors currently hold. We do not know whether board competitors will match the full increase. And we do not know how long the new pricing will remain in effect. The report is best understood as powerful evidence that pressure has now reached yet another memory category. NorFlash was once treated as a sleepy, stable, mature component. Now it is being reshaped by the same forces convulsing DRAM, board, NAND, HBM, and enterprise storage. AI demand is rewiring investment priorities across the entire memory supply. Board chain. Board, my take. My take is that the 25% increase matters less as an isolated number than as a flashing warning signal. The memory supercycle is radiating outward. It started with the obvious products: HBM for accelerators, server, DRAM, and enterprise SSDs. Now the pressure is reaching the tiny chips that store the code required to wake up: board, cars, routers, robots, and industrial systems. These devices are not glamorous. They do not appear on benchmark charts. Most consumers will never know which company manufactured them, but modern hardware absolutely depends on them. Giantech's decision reveals that mature memory can become strategically vital precisely because the industry spent years treating it as unremarkable. Supply is constrained, qualification cycles are slow, demand is growing more sophisticated, and manufacturers are concentrating investment elsewhere. That combination creates genuine pricing power. The final impact may not be a dramatic 25% jump in the price of a car or server. It may surface as delayed production schedules, compressed margins, redesigned products, and manufacturers paying stiff premiums to secure guaranteed allocation. China's domestic memory industry could eventually add enough capacity to relieve the pressure, but today one of its own suppliers is signaling loudly that the shortage still has serious bite. So, what do? You think? Is the NorFlash increase just another temporary spike, or is it proof that the AI memory crisis is now reaching every single layer of modern electronics? Let me know your view in the comments, and subscribe to Empire of Tech for more sharp, grounded coverage of the chips factories and engineering decisions reshaping the global economy. Because the next hardware bottleneck may not be the processor everyone is watching, it may be the tiny memory chip that tells that processor how to start.